Alright, here we go. 2015 FRQ question number 2. So this one's a circuit problem. We have a student wants to set up a light bulb and a resistor in series and then try to answer a couple questions here. So yeah, so let's go ahead and set this up and figure out what we want to do to answer these two questions. So do few electrons leave the bulb then enter the bulb? So it's going to be dealing with our current. Does the electric potential energy of electrons change while inside the bulb? That's going to be dealing with our voltage or electric potential. So let's go ahead and do this. They want us to describe a procedure and how to do this. So first of all, let's just set up the circuit and I'll kind of explain what we're going to do, and then we'll write it up. So we're going to put an ammeter here. Remember, ammeters need to be connected in series with the circuit. Let's call this our light bulb here. And we're going to put another ammeter after. And that's because we want to measure the current coming into the bulb and the current coming out of the bulb. And then we're going to put our resistor in series with our light bulb. So let's just call this light bulb. Let's call this resistor. This will be our voltage source. Voltage source. Okay, if we want, we could make it a variable voltage source. And one more thing we're going to do, we're going to connect our voltmeter up in parallel with the light bulb so that we can measure the potential difference across the light bulb. Alright, so you should write some procedure basically that's explaining what you're going to do, state the measurements you make. So I kind of just did that verbally. I guess I could write that down as well. So let's call this ammeter number 1, ammeter number 2. So I guess I'll say it. So we're going to connect 2 ammeters in series with our light bulb as seen to measure current and voltmeter is connected in parallel with the bulb to find the potential difference across the bulb. Okay, let's see, anything else they want to make sure we have? State the measurements you make, equipment to make them, neat label diagram. Okay, I think that's good. We're going to talk about it later in what they're going to ask us to do. So letter B says, how can you answer the two questions? So number 1, find the current. So we're going to find the current before entering the bulb using ammeter 1 and the current after using ammeter 2. Okay, what's the question again? In 1 second, do fewer electrons leave the bulb than enter the bulb? So we should be able to figure that out. We'll just go ahead and say, we'll just look at the currents, right? So if the currents, let's call I1 is greater than I2, then fewer electrons leave. entered. Okay, and I guess we should put a justification. Remember, I equals Q over T, or Q equals IT. So really we're looking at the proportionality between the charge and the current, right? Q is proportional to I. Okay, and we do know, hopefully, that in a series circuit they should be the same. So the current should be the same there. So letter 2 or number 2, how does the potential energy change? So remember, potential energy, that's proportional to our voltage. And what our voltmeter is going to do, it's going to find the potential at this point, it's going to find the potential at this point. So if it changes, then you'll get a reading here, either positive or negative reading, depending on how you set it up. So that's what essentially what we're going to do. So let's write that. So measure the voltage across potential difference across the bulb. Okay. If it's non-zero, then the potential energy has changed. Okay, and if it is 0, then it hasn't changed, right? So that's kind of what you're looking for here. And again, we know that it should change, right? So it goes across the bulb. Okay, next question says, a light bulb is non-ohmic if the resistor changes as a function of current. Setup from part A is used or modified to determine whether the light bulb is non-ohmic. How, if all, does the setup need to be modified? You don't really need to modify it. I'm not sure if they're asking for the best setup here, or if they're saying, oh, you know, does it need to be modified? If it does not, then you know, you're going to get it wrong. But I personally would change the circuit into a much simpler one. You don't need that resistor at the beginning. So I would create a new circuit like this. Here's my light bulb, and just measure the voltage here across. Okay, so I guess we should talk about this. Remove the resistor to simplify the circuit. Okay, and I'll probably talk about this later when we get to the error section, why that would be important. So what additional data, if any, would need to be collected here? So the way I would do this to figure out if it's ohmic or non-ohmic is I would create a variable situation where the voltage source is going to be changing here. So I would say we're going to take multiple measurements. Measurements of voltage and current. Okay, so for example, we'd want to go something like this. Voltage, current, so 1 volt, 2 volts, 3 volts, 4 volts, etc. And we'll get our current reading, okay? Whatever it happens to be. Okay, and I guess I'm already moving into part D here. Part D is asking, well, how do you know if it's non-ohmic? So what we would do is we'd go ahead and graph the data here. Voltage versus current, or current, doesn't really matter which one. Okay, so I guess if I made this my independent variable, we should put voltage on the bottom, current on the top. right? So we're going to go ahead and plot it. And if it's a linear graph, if the graph is linear, then we know it's a nice proportion, right? We know since V is equal to IR, if the graph is linear, then let's just write it, the resistor is ohmic, because, right, V equals IR, so there's a nice proportionality there. This is a nice linear relationship, right? So if V was doubled, I would be doubled, and so forth, if R is just simply constant. And if R changes with current or with voltage, then that we would get a different graph. We get essentially a nonlinear graph. So for example, if our graph looks something like this, okay, V versus I, and this would be nonlinear, right? This would be non-ohmic in this case. Does not follow Ohm's law. It's not a linear graph. All right, and of course you could find the resistance here. If we found the slope of this, our slope would be what? I over V, which would be equal to 1 over R. That would give us our slope if we wanted to find that. You could easily find the resistance. And again, if it's linear, then this is going to give us the value of our resistance, and it's constant. Whereas if it's like this, our resistance is continually changing here. Okay, anything else they're asking for? Discussion how the uncertainties would affect your argument for concluding whether a resistor is ohmic. This one is kind of a slightly tricky question. I would go back to up here where they are talking about voltmeters are marked with 0.1 increments, ammeters are marked with 0.01 amp increments, which basically means that the current is going to be, this becomes an issue. So if resistance is high so that current is low, okay, the precision of this is going to affect whether we, how accurate it's going to be. So for example, if resistance current is low, then the ammeter not give a, I guess, precise enough or accurate. Okay, so for example, if, let's say R happens to be 1 kilo ohm, right? That means, and for one, let's say V is 1 volt, that means our current I is going to be 1 milliamp. But the precision of this will only go to 10 milliamps. That means for 1 volt, that's going to give you a reading of, well, probably just simply 0. It won't be until 5 volts it starts giving you a reading of 1 milliamp, 10 milliamps, right? And that would continue 6, 7, 8, 9, 10, right? 10 volts would also give you 10 milliamps, all the way up to probably 14, and so forth. So what you can see is happening here is, if you plot the graph, it's going to look kind of like a step scale. And, you can't necessarily conclude that it's ohmic here. You can't tell, oh, is it going to be linear or is it taking on a curve, something like that. So that's how I would answer that question. And yeah. All right, if you have any questions, let me know.